define our problem and let's understand what is simple linear regression. So, simple linear regression is a statistical method used to predict the value of one variable called the dependent variable and based on the value of another value called the independent variable by fitting a straight line to the data. Simple linear regression with one independent variable, also called the explanatory variable, and one dependent variable, also called response variable. In simple linear regression, the dependent variable is continuous. As a previous episode, I have told you that in simple linear regression, there is only one input variable and only one output variable. And the model want to get the best fit line that is called regression line. So basically simple linear regression use this formula. Uh, I know you all are able to understand what is this formula y equals to mx plus c. This formula is belongs to uh, a formula of line, equation of line. Okay, and in machine learning for y, we can say it predicted variable like output variable, or x is input variable, m is slope, and c is intercept. And thus, let's do it little back. Okay, so you can see this. This is the linear regression line. This was black, and the dot is this orange dot is the value or the input data. In this, there is written that, or in our data, or for example, you can understand that a student who learn 0 hour score 60%, and a student when they learn 1 hour scores approximate 65%, and for 2 hour it's get 70%. You can see the study hour, the hour of study has increased, so the output variable like score also increase. Okay, so y is response variable, m is slow, the slow, this one is slow, and this is intercept. Okay, before going after that, I think you can understand now. So let's go for the code. So before building the model, we need to load and prepare our data. Okay, so I have already loaded the data. I'm going to use Pandas, Matplotlib, and Plotly and Scikit-learn. Okay, so I have just run this code, and now I have created this data set in which the data contain year of experience and the salary. A person with 1 year of experience have $40 in salary. Okay, so let's start. Here is I have defined x variable and y variable. Okay, now the time is to train the model. I'm just simply take the uh, linear regression. Okay, so I have just did this, and you can see you got. After that, we are going to get the slope and intercept. We are going to find out the slope and intercept of the given data. So I have just run it, and you can see 0, the equation is y equals to 0.20x plus 50. Okay, and for predicting the salary, for a model which have to predict that input variable means year of experience. So we are going to predict for input variable 8 how much salary will be. So you can see the salary will be 516, sorry, 5 lakh $1,600, 51,006, sorry for that, $51,600. Okay, and here I have just made a plotting using scatter plot, and you can see here this is the actual data. As such, in real world, there is not a best line, best a data that not contain such a linear line. So for this condition, we the simple linear regression wants to get the best fit line. In this case, this red line is the best fit line. This is called regression line. So you can see for 1 year of experience, a guy get or a professional get $40,000, and for 2 years of experience, $45,000. Okay, and as experience or year experience is increased, the salary will also increase. Here I have just used a plotly in this code to show this chart in a interactive manner. So here you can see that uh, for 1 year of experience, you can get $40,000 in salary. For 2 years of experience, you will get $45,000. Okay, and so on. Okay, for $70,000. $70,000. I'm here to predict that in this line, in this code, I'm going to predict that for 12 years of experience, how much salary will be for a person. So there is $95,000. And here, if I will change to 10, then you can see that for 10 years of experience, the professional gate, the salary is $52,000. I'm I in this code I'm using another example to showcase the linear regression. So I have just used a simple data set with two columns, house like size and price. Okay. So as in previously I have loaded all the libraries. So in this example I'm not going to use library for the first step. You need to load the libraries. And here I have defined the my data. If you want to see the data, then here you can see this is our data. Okay. And here I have defined the independent and dependent variable. I have train the model. Okay. And here I have got I have take the regression line. Like I have find the regression line equation, regression line equation. So for here, I'm going to predict the house prices, and this is the code using Plotly. In this code, you can see that if the if the size of the home is 500 square feet, then the actual price is $150,000. And as the size increase, the price will also increase. So for the 1500 of square feet of size of any home, have the price is $350,000. Okay, and here I'm simply just use the new size for the house and get the price as this. You can see. Okay, and if you want to check another, like if you want to check for in low amount of like 200 a square feet of home size, what will be the price of the house? So just you can get like $90,000. Okay, so we have done with simple linear regression with code and with two examples. Just to start working on it, and yeah, do practice to understand, to take in practice the models. I'm not going to explain you the code intuition and mathematical things, but if you guys want, then just comment it out. I will also explain it in another videos. So if you like this video, don't forget to like, subscribe and comment with any question and any feedbacks. See you in next time. Thank you.